Hello everybody. Today we are going to see about the SOP minimization using karnaugh map. First we will see what do you mean by karnaugh map. It is used to simplify a boolean expression which reduces the circuit complexity, cost and space. What do you mean by boolean expression? Each and every variable in a boolean expression will consist of either 0 or 1. Okay. So this karnaugh map is the one, it's an array of cells which are arranged in such a way they differ only by 1 bit. If there are n variables means there will be 2 power n cells. Okay. So using the karnaugh map you can reduce the expression which in turn will be reducing the circuit complexity, cost and space. Okay. What are all the steps involved in minimization using karnaugh map means you have to map the truth table. What is the truth table? It gives the combination of values for all the variables present in the domain and what is the output for each combination. Those values you have to map in the karnaugh map and you have to group the cells. What do you mean by grouping means adjacent cells you can group. Okay. For a 3 variable karnaugh map, you will be having this is let it be A and this portion is BC. This is a grid, okay, which consists of this 8 cells. Okay. So for BC the combination is 0 0 0 1 1 1 1 0 and for A it is 0 1. Normally the order will be 0 0 0 1 1 0 and 1 1, but why we are writing 1 1 first and 1 0 next means the karnaugh map arrangement is in such a way the adjacent cells should differ only in 1 bit. So if it is in this order means 0 and 1 also varies, 1 and 0 also varies. Okay. If it is here, it is in this order 0 1 1 1 1 0 means this is adjacent because they differ only in this, and these two are adjacent because this differs by 0 and 1, and these two are adjacent because it is differ in this least significant bit. So that only the karnaugh map arrangement of values in such a way they differ only by 1 bit in the adjacent cells. In the karnaugh map this cell and this cell is adjacent, and for this is adjacent. I mean these cells are adjacent. Okay. For this cell this is adjacent, and it is not adjacent diagonal wise. It is not possible. Okay. So this is the arrangement of karnaugh map. It maps all the truth table and group the cells. Grouping in such a way that is you can power in the powers of 2. 2 power 0 means one group, the group consists of only 1, and 2 power n is 2 ones if it is in the SOP case. Okay. SOP is nothing but it is the boolean expression formed by ORing one or more product terms. This is one product term and this is another product term, this is another product term, and they are summed up. Okay. So sum of products, these are all the products, you are summing it up. So like this type of expression comes under SOP. Okay. So you have to group for SOP ones. Okay. How many number of ones? So you can group in such a in the powers of 2. Okay. In the group of 1 ones, 2 ones, 4 ones, and 2 cube is 8 ones, and 2 power 4 is 16 ones. Like that only you can group. Okay. Now we'll see one example for SOP minimization. Let the expression be f1 is equal to, for min term it is this summing of the values. Okay, let it be the summation of 0, 2, 4, 5, 6. This is the expression given. And these are all the, actually the min terms. This is called the min term. That is the product term. Okay. So what is this 0? It is nothing but there are, what is the highest number here? 6. To represent this, you need 3 bits. So 3 variable is needed. So let it be A, B, C. Okay, 3 variables. So for 0, it is A dash, B dash, C dash. What is the binary equivalent of this? 0, 0. What is the binary equivalent for 2? It is 0, 1, 0. So for 2, it is what? For A, it is A dash. This is B. And this is C dash. Okay. So for this terms alone, you have to fill the karnaugh map with ones. Okay. So let me draw the karnaugh map first. So here you have 3 variables. So let it be AB and C. So here AB means 4 combinations. Yes, what are they? 0, 0, 0, 1, 1, 1 and 1, 0. Okay. And here it is nothing but for C, only 1 variable. So only 0 and 1. Okay. So this is nothing but 0. This cell is nothing but 1. This is 2. And this is 3. This is actually 4. 1, 0, 0 is nothing but 4. 1, 0, 1 is nothing but 5. 1, 1, 0 is nothing but 6. 1, 1, 1 is nothing but 7. So now you have to fill with 0 as 1. Okay. And then 2 is also 1. And 4 is also 1. 5 also 1. 6 also 1. Okay. Now what we have? So now you have to group. Now we have filled what all the terms available. Then in SOP you have to fill with the 1. Others you have to put it as 0. Now you have to form the group. Okay. Now how will you group? I told the adjacents in terms of the number of 4s. 4 ones are there. So you can group it. Okay. And this one is having the adjacent 1 over here. That also you can group it. Now after grouping, each group you have to assign with product term. How will you assign a product term? These 2 ones, okay, this one belongs to this 1, 0. And here the 0, 1 are contradictory. You have to leave out the contradictory variables. Okay. So here you have only A and B dash for this grouping. And what about this grouping? So this consists of only C. Okay. C dash must be there. And these are all contradictory. So you have to leave it. So just you will be having C dash. Okay. So now the minimized SOP, these are all the, after grouping you have written the product terms. Now SOP means what? Sum of products. These terms you have to just add it up. So this is the minimized SOP. In next video we will see about the minimized POS expression. Thank you.